A customer writes HarborSoft support, my order arrived cracked, and I want a refund. Out of the box, Llama 3.2 answers like a brochure long formal and unsure about your real policy. HarborSoft needs short, warm policy, safe replies that sound like the brand, not like a textbook. Today, you will fine-tune an open source model with Unsloth and LoRA so the adapter learns that voice. Picture Stitch Bay, the big model is ready-made cloth. LoRA is the thin alteration stitch you sew for HarborSoft. We walk the desk slowly, dataset install, train script line by line, then a before and after on the same ticket. The same recipe works on Phi 3. In this lesson, the base cloth is Llama 3.23b Instruct. First, decide the job. Retrieval augmented generation pulls facts from your files at ask time. Fine-tuning changes how the model writes tone, length, refusal habits, and reply shape. If the miss is a wrong policy, quote builder. If the miss is the wrong voice, stitch a LoRA. HarborSoft already knows the refund rule. The pain is that every reply still sounds generic. Full fine-tuning rewrites billions of weights. That needs huge memory and is hard to ship. LoRA freezes the base model and trains a thin adapter of low-rank matrices instead. You save that adapter as a small folder. The huge base weights stay shared and reusable. QLoRA keeps the base model in 4-bit memory so one consumer GPU can train the adapter. Unsloth wraps that path with fast kernels. You still speak LoRA honestly adapters, not magic. Open the support replies JSON file. Each line is one teaching example for brand voice. Instruction tells the model who it is: HarborSoft support, short, warm, and policy safe. Input is the customer ticket. Output is the gold reply a senior agent would send. Read the cracked order row. The gold reply apologizes once, confirms the refund, and names the wait window. Read the free shipping row. The model must grant free replacement shipping when arrival damage is real. Read the warranty rope. The gold reply refuses a lifetime promise because that is not policy. A small clean set beats a noisy dump. For teaching, we use a handful of sharp pairs, then you grow the file at work. Open the Unsloth GitHub page. This is the toolkit that loads Llama fast and wires LoRA for you. Look at the About panel on the right. Fine-tuning is listed as a core topic this toolkit owns. Open the Hugging Face card for Llama 3.23b Instruct. That is the base cloth for this stitch. Unsloth also ships a matching Llama 3.2 package. Same family, ready for 4-bit load. Open a terminal. Make a folder called Stitch Bay under your projects directory, then move into it. Create a Python virtual environment. Isolation keeps Unsloth and CUDA wheels from fighting other projects. Activate the environment. Your prompt should show the ven name before you install anything. Install Unsloth with the command from the REA daemon for your CUDA version. Wait until pip finishes cleanly. Confirm a GPU is visible to PyTorch. If CUDA is false, stop and fix drivers before you train. Copy support replies JSONL into the folder. The train script will read that file, not invent tickets. Open Visual Studio Code on Stitch Bay. You should see the JSONL file, train support LoRA, and infer support. Import fast language model from Unsloth. This class loads the base model and later attaches LoRA. Import load dataset from the datasets library. That helper reads your JSON into training rows. Import SFTTrainer and SFT config from TRL. Supervised fine-tuning is how we teach reply habits. Call fast language model from pre-trained. This is the line that loads the base cloth into memory. Pass model name Unsloth Llama 3.23b Instruct. That string must match the card you opened. Set max sequence length to 2048. Longer tickets still fit without blowing VRAM for this lesson. Set load in 4-bit to true. That is, cool array the base stays compressed so one GPU can train. Close the from pre-trained call. You now have a model object and a tokenizer that share the same chat template. Call get PEFT model on fast language model. This freezes the base and prepares LoRA slots. Pass the model first. LoRA wraps this object. You keep training the same variable name. Set rank R to 16. Rank is the width of the stitch. Bigger learns more, costs more memory. Target the attention projections Q, K, V, and U. Those layers shape how the model attends while writing. Set LoRA alpha to 16. Alpha scales the adapter strength relative to rank. Set LoRA dropout to 0 for this small clean set. Dropout helps when the dataset is huge and noisy. Set bias to none so only the LoRA matrices train. Close the get PEFT model call. Load the JSONL with load dataset. Split train means every row is used for teaching in this lesson. Define format row. This function turns one ticket into a single chat template string the trainer expects. Build a 3, turn chat system from instruction, user from input, assistant from output. Apply the tokenizer chat template with tokenize false. You want text for SFT, not tokenids yet. Return a dict with key text. The trainer looks for that field when it builds batches. Map format row across the dataset. Every ticket is now a properly wrapped training string. Create SFTTrainer. This object owns the training loop for supervised reply teaching. Pass the LoRA model. If you pass the frozen base alone, nothing useful learns. Pass the map train dataset. That is the Harbor soft voice the adapter should copy. Pass the tokenizer so packing and chat special tokens stay correct. Open SFT config. These knobs decide how long and how hard you stitch. Set output dir to stitch bayout. Checkpoints land here if training is long. Set per device train batch size to 2. Small batches fit consumer VRAM with 4-bit weights. Set learning rate to 2 times 10 to the minus 4. LoRA likes a higher rate than full fine tunes. Set num train epochs to 3. On a tiny set, 3 passes are enough to hear the brand shift. Set logging steps to 1 so you see loss move every step while you learn. Close SFT config and the trainer constructor. The stitch machine is armed. Call trainer train. This is the line that actually updates the LoRA weights. In the terminal you should see step logs and a falling loss. If loss never moves, stop and check the dataset map. Save the adapter with model save pretrained into support LoRA. This folder is the stitch you ship. Save the tokenizer beside it. Inference needs the same chat template the train used. Open infer support. This small script loads the adapter and answers the cracked order ticket. Load from pretrained with model name support LoRA. Unsloth picks up the adapter folder you just saved. Call for inference so Unsloth switches out of training mode and speeds generation. Build the same cracked order messages, then generate. Compare the new reply to the brochure tone from the hook. Watch the before and after. The base model wrote a brochure. The adapter writes a Harbor soft reply. The after reply apologizes once, confirms the refund, and names 3 to 5 business days, like the gold row. Ship the adapter folder separately when you can. One base model can wear many business stitches. Merge only when your serving stack cannot load LoRA at runtime. Merging bakes the stitch into full weights. Never put API keys or private ticket text into the public adapter card. Scrub the dataset before you share. Hold out a few real tickets for evaluation. If the voice drifts or invents policy, add gold pairs and stitch again. Stitch Bay Maparaji for facts, LoRA for voice, QLoRA for 1, GPU training, Unsloth for speed. When the next cracked order lands, do not rewrite the whole cloth, sue the Harbor soft stitch and prove it on that ticket.